Hi, and welcome to the Learn Kubernetes with Google series. My name is Laura, and I'm a software engineer here at Google working on managed multi-cluster in GKE. In this video, we're going to talk about services, one of the fundamental concepts in Kubernetes. Service objects are what describe to your Kubernetes installation how your pods can talk to each other, or how things out in the internet, not in your Kubernetes cluster, can talk to them. In this video, we assume you know about the Kubernetes API and have used kubectl or the REST API to create objects in a Kubernetes cluster before. If not, feel free to follow along anyways, we just won't be spending too much time on explaining that. You can always check the documentation for the basics, which I've linked in the video description. So, let's get started. Ta-da! This is a service object. Like anything in the Kubernetes API, you can create this object on your Kubernetes cluster, like with this kubectl command, and the Kubernetes control plane will do its best to make it a reality. One thing that trips people up is that there are many different types of services, and what your Kubernetes control plane will try to do when you create them varies wildly depending what type you ask it to create. So what we're going to do is go through each of these one by one. I'll tell you what they are good for and what configuration you usually set for each type. So let's start with our first example. This is the most basic type of service, the ClusterIP type. The whole thing about a ClusterIP service is that it asks Kubernetes control plane to expose one IP, which you can configure here, for all the matching backing pods that match this selector here. The idea is that for any pod in your cluster, if it tries to contact this cluster IP, 10.108.16.2, the pod answering the phone at the other end of the line will be one of the ones matching this selector. So let's say we have another pod that's a front end. It needs to request something from these pods behind our service. So here's part of a deployment for something like that. In the application code for our front-end pod, we will configure to use just one cluster IP, and then Kubernetes will deal with actually routing those requests to the individual pods backing the service. So here in my front-end's back-end server environment variable, it has this value, which is the IP address from our ClusterIP type service. So now Kubernetes will make sure that this IP address only routes to pods that pass their readiness checks, that are ready to accept traffic. If some of the pods go away or become unhealthy, no sweat on us as application developers because the cluster IP stays the same, even if the pods behind it change. So that's the exciting part about putting this service abstraction in the middle between us and our pods. So I picked this service configuration to show you the details, but you can let Kubernetes do even more of the work for you with ClusterIP type services by not even specifying a spec.clusterIP. So now the Kubernetes control plane will pick the cluster IP for you from the pod CIDR range it gets when it first starts up. So since you're not setting the cluster IP yourself, you don't know what it is until the control plane actually provisions it. So here it happens to be 10.1.12.1.7, but we don't know that ahead of time. But if you use the DNS add-on, which most Kubernetes installations actually include, in your application code, you will actually add in just the DNS name for this service. So it always follows this one format: service name, then namespace, then these three letters SVC, then cluster, then local. This DNS name will route to the cluster IP that Kubernetes picked for you, which itself routes back to the pods matching the service selector. So over in our front-end configuration, we drop in the DNS name and we don't care what the actual IP address is. One more little detail. For ClusterIP service types, you can actually skip this whole line here where it says type ClusterIP. It's the default service. So if you don't say anything else, that's the type Kubernetes makes for you. All right, let's look at another one. What? A ClusterIP service where IP is none? What could that mean? Maybe this is confusing since we were making ClusterIP services so we would have the one dedicated IP for all matching pods, right? So the situation is that sometimes people want to be more specific about which matching pods their application routes to than the ClusterIP type is really designed for. They'd like to select from the available pods themselves instead of throwing in the one ClusterIP or the one DNS name and letting Kubernetes decide which matching pod you get back. So the way that's made available to you with a service type is to set ClusterIP equal to none. So we actually call this a Headless Service. So this is a new type of service, but it's actually a riff on the existing ClusterIP service. So you don't actually change the type field. Instead, you use the special configuration in the spec.clusterip field. But anytime someone is talking about a headless service, they are talking about this type of configuration where type equals ClusterIP, but the spec.ClusterIP field is set to none. So what will a Kubernetes control plane do differently when it receives an API request with an object looking like this? Because spec.ClusterIP is none, it won't provision the one true IP to rule them all. Instead, it will set up DNS records that return the pod IPs of all the matching pods from that service selector, and that is what you will get back whenever you try and request the service. So over here in my front end, I have the same DNS name, the one DNS name for my whole service, but when my application tries to resolve that DNS name, it will get back not one IP, but as many IP addresses as there are backing pods. So if I have 3 pods matching the selector for the service, then my application gets back 3 IP addresses, one for each matching pod. In fact, here is NS lookup from inside my front-end deployments pod against our Headless Services DNS name. You can see I'm getting 3 IP addresses back for this one DNS name for a service, this my-service.demo.svc.cluster.local, because my pod deployment behind this service had 3 replicas. So if you set yourself up like this, your application can use this information to choose itself which matching pod it should route traffic to. So maybe your front-end application code uses this backend server environment variable, resolves the IPs, but then it does some special application logic to decide which one to actually make the request with. Maybe it keeps a tally of who it contacted last, or targets pods with a certain host name based on some logic, whatever it is. The point is that Kubernetes control plane isn't picking for you. You can pick yourself. We're just using Kubernetes to tell us which pods are ready to accept traffic and match the selector, and then you can pick from those how you like. Okay, let's carry on. 3 more types of services to go. So the 2 we've been talking about, ClusterIP and Headless, they're used for communication within the cluster. That ClusterIP that Kubernetes provisions for the ClusterIP type service, or the IP address list you get back for Headless Service, the idea is that you would use those from another pod in the cluster. So 2 of these other ones are for another type of situation, where you have something outside of the cluster trying to talk to the pods inside of the cluster. To make those pods accessible, you can use one of these 2 types of services. So for this reason, this blue group here can also be referred to as published services, because using these service types means you are publishing a way to get to their selected pods to consumers who are outside of your cluster. So let's start with this first one, NodePort. The NodePort type tells the Kubernetes control plane to open up a port on each node in your cluster that leads to all the pods matching the selector for the service. So this is a way for any external consumer to ask, hey, can I get to some of the pods in there? Because if they have the node's IP address and the port that the NodePort type service was published on, then the Kubernetes control plane can route the request to the correct pods. So this one kind of needs a little diagram. So let's get a little diagram going here. Let's pretend this is my Kubernetes cluster, this whole gray square, and it's composed of these individual nodes. And the nodes have pods, deployments running in them, control plane processes, little etcd here, little etcd there, normal Kubernetes node life. And in my case, each of these nodes are a VM, they're a computer somewhere, right? They're networked to the internet and they have external IP addresses assigned to them. So this green one has the IP 34.66.63.232. And then let's say my front end is hosted somewhere else now. It's not in my cluster, it's outside. So it's in another cluster, or it's on just one VM somewhere, or it's a static site hosted in a cloud storage bucket or something. The important part is it's not inside the Kubernetes cluster where the yellow pods are, and it wants to talk to the yellow pods. So somewhere in my application code, I'll set any requests that need to use the service hosted at the yellow pods to use this node IP port combination. So when this request reaches my Kubernetes cluster, because I have a NodePort service that is publishing the way into my cluster for these pods at that port, it will know this request is looking for the yellow pods and will route the request appropriately. So this backend server variable here, it's composed of the external IP address for the green node and then the port we actually exposed on the node with the NodePort service type. So you can probably already see a downside to this. We're only targeting one node at a time. Our application is choosing, I'm going after the yellow pods in the green node, but what about the yellow pods in the blue node or the yellow pods in the orange node? Since each node has its own IP, you could keep adding some more application logic, try to route around them. That starts to get annoying. So this is the segue to the next service type, which is the load balancer type. All right, so we're going to solve this problem. We have to put another middleman in here. But the idea of the load balancer type is if we don't want our application code to have to decide which node we're targeting, we can use a load balancer type to provision something in between that will do that for us. So this only works out of the box if you are running your Kubernetes cluster in a cloud provider like GCP, AWS, Azure, etc. The reason is because this load balancer here, it's not part of the cluster, it's outside the cluster. It has to be made as another thing altogether. It's not using the same compute resources as your Kubernetes cluster is running on. So the Kubernetes control plane on those cloud providers knows how to provision an external load balancer in those clouds. So when you make this load balancer type service, the Kubernetes control plane gets to work on its part. It makes some hidden ClusterIP type and NodePort type services for you. But then it also asks your cloud provider to pretty please make me a load balancer, and here are the node IPs and ports that you should load balance around. So depending on your cloud provider, you can configure what IP address that load balancer will be available on up front in your load balancer service object. Otherwise, your cloud provider gets to pick, and so then you'll have to check the load balancer resource in your GCP console or gcloud or AWS console, whatever it is, to find out what the external IP is for the load balancer so that you can actually throw that into your external applications configuration. But in my little example here, I set my spec.loadbalancer IP to 34.66.63.239. And I configured my front end with that IP address. So then the requests are going to go through the load balancer at that IP address and route back to all the nodes in my Kubernetes cluster in the back here. So my application code stays the same. The load balancer is the one that's handling the details of which node each request gets routed to. All right, folks, last service type, external name type. If you check the documentation, this is actually under the heading for published services, but I think it's a bit more unique than that, so I didn't put it in the same blue group, but let's take a look. So the point of the external name service type is basically just to do simple one-to-one routing between the automatically made service DNS name and some other DNS name or IP address that you have in mind. So it's for people who like the automatically generated service DNS name and to route that one-to-one to something else. So we talked earlier, if you're using that DNS add-on, which most people probably are, that every service object you create is going to have a DNS name that looks like service name, the namespace, those letters SVC, then cluster, then local. So let me put the example up here. Here it is, my-service.demo.svc.cluster.local. That's service name, namespace, SVC, cluster, local. So this is the DNS record we would expect to be made for this external name service, just because it's a service object and that's what the DNS add-on does to service objects, right? So what we were doing with this part here, the spec.externalName field, we're telling Kubernetes, hey, anytime someone tries to go to the DNS name you make for the service, actually send them here. Send them to whatever I put in the spec.externalName field. So here in cluster, any request to the DNS name my-service.demo.svc.cluster.local will actually route to the IP address 34.66.63.214 because that is what we put in the spec.externalName field. Usually the situation is that the spec.externalName is an IP address or DNS name available externally from the cluster on the internet. So it's more about making the pods in the cluster. When they try to access the service, they get sent out somewhere external to the cluster. That's why I feel it's a bit special compared to those other two published services. It's to make pods in the cluster. When they try and access a service by its normal Kubernetes name, get bopped out to somewhere else that you specifically name in the spec.externalName field. So the example in the documentation for this is maybe you have a database outside of your cluster. It's accessible over the internet by this DNS name, my.database.example.com. You set it up like that, or another IT department set it up elsewhere, whatever, that's where it is. Not in your cluster, but you want to access it from your application that is hosted in your cluster. You can make this external name service, set up your application code everywhere to use the my-service.prod.svc.cluster.local DNS name, and then one day, you get the green light to move the database from its special my.database.example.com location to be inside your cluster. Once you've got it all set up in your cluster, you can just switch out the service type so that it's not external name anymore, but ClusterIP type. And the DNS names you use in your application code can all stay the same now. And Kubernetes does the work of rerouting to the pods that are now in cluster for this database. So there you have it. Those are all the different types of service objects and how they work in your Kubernetes cluster. Hopefully you have a better idea of what they're all used for and how to configure them. There are a lot more details and examples in the documentation on services. So I definitely suggest you give the docs a read now that you've got an overview here. I put the links to the documentation in the video description so you can get to it easily. And on top of all of this, there are actually some other Kubernetes APIs that help with networking, especially the blue circle over here about out-of-cluster communication. If you look up the Ingress or Gateway APIs, you'll see there are a whole lot of other options. But we will have to save that for another video, and I'll just throw the links into the video description for now in case you're curious. So that's it for this one. Thank you for joining me for this episode of Learn Kubernetes with Google. My name's Laura, and we will see you next time.